So within this revision video, we're going to explore some of the ways that human activity is having an impact on the stores and flows of carbon within the carbon cycle. The first impact that we're going to consider is how human activity is influencing and altering the greenhouse effect. It's perhaps worth us starting by thinking about what the greenhouse effect is and how it works, because this is often an area where people have a few misconceptions. So the diagram on the screen shows us the greenhouse effect. This is a natural process by which gases within our atmosphere, greenhouse gases, absorb long wave radiation or heat energy being released by the Earth. We can see in the diagram that energy is transmitted from the sun towards the Earth. Okay, now most of that solar energy will be absorbed by the planet. We can see here that the net incoming solar radiation is about 240 watts per metre squared. Some of that sunlight though will actually bounce off of gases or clouds within our atmosphere, so some of that energy is reflected before it reaches us, and also some of it will actually bounce off of the surface itself. So some surfaces like snow and ice have quite a high reflectivity, what we call a high albedo, and that means that the sunlight is reflected. But as we can see here, that some of that solar energy is absorbed by the Earth's surface, and basically it warms up the Earth's surface. In this case here, about 168 watts per metre squared of energy is being absorbed. Now, the heat released from the Earth is in a different form of energy. The energy coming in from the sun is shortwave ultraviolet radiation, whereas the energy being released by the Earth is long-wave infrared radiation. So some of that heat will escape out to space. It will travel through our atmosphere and it will be lost out to space. Some of it, however, will be trapped by this layer of greenhouse gases that we have within our atmosphere. Things like carbon dioxide and water vapour and methane are going to be trapping those gases. This is a perfectly natural process. However, human activity is speeding this process up, or it's enhancing it. So when we talk about human activity affecting the carbon cycle, we really want to be talking about the enhanced greenhouse effect. And that is because human activity is increasing the concentration of these greenhouse gases, and therefore we are making this effect more intense. In fact, another phrase that we use to associate with the greenhouse effect is radiative forcing, and this is the difference between the balance of incoming solar radiation and outgoing heat radiation. Now if we look back at our diagram, you can see that we had 240 watts per metre squared of radiation coming into the Earth from the sun. So that's the amount of incoming solar radiation that we've got on the planet. If we look up here as well, the net outgoing infrared radiation, the amount being lost by the planet, this outgoing heat, is also 240 watts per metre squared. But that is assuming that the concentration of greenhouse gases in our atmosphere isn't changing. However, we know that the concentration of those gases is changing as a result of human activity. So what's happening is for every metre squared, 1.6 watts of energy is not being lost out to space. So we've got this imbalance between the amount of energy coming in from the sun and the amount of energy leaving, and that's because those greenhouse gases are trapping heat within our atmosphere. It's really important to stress that the greenhouse gases are trapping heat released by the Earth. They are not trapping sunlight. That is a very, very common misconception that people have here. This is not trapping heat from the sun, it is trapping heat from within the Earth. So over time we can see how the concentration of particularly carbon dioxide, a very important greenhouse gas, has changed within our atmosphere. The graph on the left hand side shows observations of atmospheric carbon dioxide taken from the Mauna Loa Observatory in Hawaii. This is an observatory that's been taking very, very long records of carbon dioxide to see how they have been changing over time. And we can see that since 1960, the concentration of greenhouse gases in our atmosphere has gone up from around 320 to over 400 parts per million. That is the measurement or unit of measurement that we give when we're referring to the concentrations of carbon dioxide. Since pre-industrial times, so since the Industrial Revolution around 1850, concentrations of greenhouse gases have gone up from about 280 parts per million to now over 400. This is a really significant change. It's an increase of about 40% over that relatively short period of time. To get an idea about the rate of change, it's important that we think about atmospheric concentrations of CO2 over a much longer period of time, because this line on the graph on the left looks quite steady. If we look at the graph on the right, this shows for the last 800,000 years how the concentration of greenhouse gases has changed, particularly the concentration of carbon dioxide. We can see that it's fluctuated again between sort of 280 and maybe 180 parts per million. Pretty much universally over that whole period of time. It's not really gone much beyond those two measurements. However, when we get to human activity here in the form of industrialization, we can see how rapidly that concentration of carbon dioxide has increased. Two things to note: concentrations of carbon dioxide have never been higher than they are at the moment in the last 800,000 years, and also the rate of increase, the steepness of this line here, has never been that quick again in the past 800,000 years. And that gives an idea of just how unprecedented these changes to the concentration of carbon dioxide in our atmosphere actually are. You may be wondering why the red line on this graph fluctuates up and down over the course of an individual year. And this is driven by photosynthesis, particularly in the northern hemisphere. So what will happen if we were to zoom in and look at maybe 1 year's worth of carbon dioxide, so we'll start perhaps with the winter here. We'll think about the summer of that year, and then we'll think about the winter the next year over here. What will happen to that amount of carbon dioxide is it might be relatively high in the winter, and then the amount of carbon dioxide will decrease in the summer as plants photosynthesize and absorb some of that carbon dioxide, and then during the autumn, when they lose their leaves and stop photosynthesizing, that carbon dioxide level will go up again. So that's what we can see happening in each of these years. We can see it starting relatively high, it drops in the summer, and then it rises again the following winter. What's happening though is each winter that rise is pushing the concentrations of carbon dioxide a little bit higher and a little bit higher again. I'm going to link to a video in the top right hand corner now, which is a very good visualization of this process if you want to have a little bit more of a look at that in some detail. It's important that we understand the human activities that are driving this increase in the concentrations of greenhouse gases in our atmosphere. We can't really consider human impacts on the carbon cycle without considering the combustion of fossil fuels. The graph on the left hand side here shows since 1800 how the emissions of carbon, how the energy consumption from fossil fuels has changed. We can see this really, really rapid rise, particularly from around 1950 onwards, in terms of the increase in the amount of energy being generated by fossil fuels. Coal in the past used to be the most dominant fuel. Certainly back in the sort of mid 20th century, coal accounted for a significant proportion, much more so than natural gas. However, more recently, the amount of coal use has actually steadied itself off and very much been replaced by the consumption of natural gas. However, all three of these main fossil fuels, gas, oil and coal, all release significant amounts of carbon dioxide when they're combusted. That carbon that was once locked away in the lithosphere now is transferred very, very quickly to our atmosphere. We release about somewhere in the region of 9 to 10 gigatons, or 9 to 10 petagrams of carbon each year just from the combustion of fossil fuels. We should also be aware of the fact that these emissions are not spread evenly around the world. If we look at the map on the right hand side, this shows us fossil fuel consumption in 2019. We can see how a very small number of countries really dominate the emission of greenhouse gases from these fuels. So particularly China, India, Australia, the USA, Canada, Brazil and the European Union and Russia as well. Those countries really significant in terms of their emissions from fossil fuels. We can't really attribute these emissions to low-income countries. If we look at Africa on this map, we can get a real sense of just how few emissions are coming from those low-income countries. It's very much driven by high-income countries and newly emerging economies. Agriculture is another really important driver of changes to the carbon cycle. A number of agricultural activities that release carbon dioxide. When we actually take into account the emissions from not just the production of food, but maybe from the fertilizers used to enrich the soil, to the storage and packaging of our food, its transportation around the world, food actually makes up about a third of all human-caused greenhouse gas emissions. These emissions have also been seeing a significant increase. They've actually pretty much doubled in the past 50 years, and estimates show that they could increase by another 30% by 2050. The main drivers of these emissions, remembering we release about 6 billion tonnes of CO2 from agriculture every year, they are being primarily driven by what's known as enteric fermentation. This is a really important concept to understand. This is driven particularly by cattle. So when cattle eat grass, they graze on vegetation. When they're digesting that grass, they create huge amounts of methane, and they burp that methane out. And methane is a very powerful greenhouse gas. It's actually 22 times more powerful than carbon dioxide in terms of causing a warming effect. Also, the way that modern intensive agriculture impacts the soil, that can also cause the soil structure to break down and for carbon to be released. Also, methane is very significantly produced from rice paddies. So anywhere that's growing rice, where those plants are submerged underwater, that low oxygen environment generates a lot of methane. So we mustn't overlook agriculture for its contribution to changes within the carbon cycle. Linked with agriculture is also the impact of deforestation. When we actually look at the graph on the left-hand side here, this shows the causes of deforestation, the main things driving deforestation in the Brazilian Amazon between 2001 and 2013. And we can see that the majority of that deforestation, 63% for pasture land for cattle to graze on, 12% for small-scale agriculture, 7% for crops here, 1% for plantations. We can see that deforestation is primarily driven by agriculture. So these two things go hand in hand. Around 16 million hectares of forest is lost each year. And if we look at the levels of emissions from deforestation, we can see that it's about equivalent to the same level of emissions that come from transport. So about 15% of our CO2 emissions come from deforestation, particularly in tropical forests, whereas transportation only accounts for 14%. So when we're thinking about how we might tackle some of these problems, reducing levels of deforestation is really important. Now, deforestation has an impact in a couple of ways. It's a bit of a kind of two-pronged influence on our carbon cycle. So firstly, when the trees are felled and they're cut down, they release carbon. Very often the areas where the trees have been chopped down are also burned, and that fire, that combustion, also releases carbon from the vegetation that's being burnt, and also from the soil that gets burnt as well. So we have this problem that when the trees are felled, they act as a source of carbon. They're releasing carbon into the atmosphere. But we also have to remember that we are also losing a very valuable sink of carbon. Normally, if those trees were left there, they would be photosynthesizing. Day after day, they would be absorbing carbon and locking it away in their structures. But without the trees there, if they've been cut down, we are losing that very valuable sink. So we're doing two things to upset the carbon cycle here. We are adding more carbon, and we are limiting the ability of one particular store to absorb carbon. The other thing that happens as a result of deforestation is that we increase the rates of soil erosion. Now that happens because without the trees there to bind the soil together with their roots, soil is much more easily eroded, either eroded by the wind or by heavy rainfall washing it away, and that means that we're also losing another store of carbon. And as we've said already, agriculture is the main thing that is driving this change. The final change we should consider as well is changes to do with urbanisation. So the Earth has reached a kind of tipping point really, whereby nowadays more people live in towns and cities, in urban areas, than they do in rural areas. And that's a really important tipping point because the links between economic growth and urbanisation and carbon dioxide emissions are linked really, really closely. That's because cities have a very carbon intensive way of life. If you live in a city, you will use more energy and emit more carbon dioxide through your daily activities than you would do if you lived in a rural area. So cities actually account for about 80% of our energy consumption worldwide. And this percentage of people living in cities in the future is only going to continue to increase. It's actually estimated that by 2050, about 70% of our population will be living in towns or cities. So that hints that in the future, energy consumption, carbon emissions are only going to continue to increase as people move to cities and then adopt a lifestyle that is much more carbon intensive. However, we shouldn't be too pessimistic about this, and we should consider the fact that the majority of this growth in urbanisation is going to take place in the developing world, particularly in low-income countries. Now, that presents a little bit of an opportunity in so much as if we can get that urbanisation to happen in a more sustainable way, then potentially we can reduce the impact that urbanisation is having on the carbon cycle. So in summary then, human activity is enhancing the greenhouse effect. We are trapping long wave or heat radiation from the Earth as a result of increasing the concentrations of greenhouse gases within our atmosphere. Carbon dioxide emissions have increased by over 40% since pre-industrial levels. They've gone up from around 280 parts per million to over 400 parts per million in the present day. The emissions from fossil fuels are actually growing, and that rate is increasing. So we are not showing any signs of things slowing down or levelling off. The rate at which we are emitting carbon dioxide from fossil fuels is actually growing. We also have other drivers of change, things like agriculture and deforestation and urbanisation, which are all very interconnected. They are adding to the emission of carbon dioxide and also methane, and the loss of natural sinks of carbon like the rainforests and the soils which naturally absorb carbon.